Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers Venn diagrams. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it.
Question 22 has got a Venn diagram showing information about a coin collection. Now we're told this curly E is the universal set and we're told there are 120 coins in the collection altogether. T is the set of coins from the 20th century and B is the set of British coins. So obviously there's a bit of an intersect where the British coins from the 20th century are. Okay, and we're told that a coin is chosen at random, it is British. Work out the probability that it's from the 20th century. Okay, now before we do that, I think we need to evaluate all these different parts of the diagram. We know the overall number in the universal set is 120, so we can form an equation in X and solve it first in order to work out what the actual numbers are in each of the sections of the Venn diagram. So let's do that first. Okay, so all the different regions of the Venn diagram should add up to 120. So we've got the x, lots of x minus 15, plus the x minus 2, and plus the 32, which is outside both sets, and that is equal to 120. So we're going to have a quadratic in x, aren't we, here? So multiplying out those brackets, we're going to get x squared minus 15x plus x and x is 2x minus 2 plus 32. I'm going to combine that into plus 30 equals 120. So x squared minus 15x plus 2x, that's x squared minus 13x, and bringing the 120 over to this side as well. 30 minus 120 is minus 90 equals 0. So we end up with a quadratic that looks like this: x squared minus 13x minus 90 equals 0. So we've got a quadratic equation that we need to solve. Always worth trying to see if we can factorize them first, because that's a lot easier than the formula. So can we think of two numbers that multiply together to give us negative 90 and add up to negative 13? Thinking about the factor pairs of 90, 90 has factor pairs 1 and 90, it has 2 and 45, 3 goes into 90 30 times. Does 4 go into 90? Yep, it does. It goes in... No, it doesn't. 5 does though. 5 goes in 18 times. Does 6 go into 90? Yep, it goes in 15 times. 7 doesn't. 8 doesn't. 9 does. 9 and 10. And I've kind of met myself coming down the other way now. So I think they are all the factor pairs. Now, do any of these factor pairs have a difference of 2? Sorry, a difference of 13, isn't it? So a difference of 13. These do 5 and 18. So x and x 1 plus 1 minus, because our answer is minus. And the larger one is going to be the negative one, because I get minus 13x. So the 18 goes here, and the 5 goes here. Now, that gives us solutions for x of x equals minus 5 and x equals 18. Now, whilst those two are both mathematically correct, in the context of this problem, the negative solution can't happen because I've got x coins in the middle here. I can't have minus 5 coins there. So although minus 5 is a solution to the equation, it's not a solution to the problem. X equals 18 is the solution. So now I know that x is equal to 18, I can put values for each of these regions on my diagram. So that means I've got 18 in the middle there. This one is x minus 2, so that's 16. And the other one is going to be 18 times 18 minus 15. 18 minus 15 is 3. 3 lots of 18. What's that? 54. 54 go in there. I think it's worth at this point just double checking and adding up all your regions and double checking they add up to 120. 54 plus 18 plus 16 plus 32, that adds up to 120. Okay, any little checks that you can do that for yourself along the way means that, well, you're not going to get any surprises when the marks come back from the test. Okay, but have we finished yet? A coin is chosen at random. What is the probability that it is British? Okay, so we haven't quite finished yet. We need to work out a probability. Work out the probability that it's from the 20th century. So we already know that it's British, so we know it must be inside the B circle. So it must be one of 18 plus 16 coins. There are 18 plus 16, that's 28, 30, 34 British coins. So number of British coins is 18 plus 16, which is 34, and number of British coins that are also from the 20th century is 18. Oops. So the probability that it is 20th century, given that it is British, is going to be, well, there are 18 there, aren't there, to pick from, out of a total of 34. Oops. 34. So 18 over 34. In question 16, we're given various information which we need to include in a Venn diagram. The first bit of information we're given is that the universal set is made up of 100 farms. So altogether the numbers inside this Venn diagram need to add up to 100. W is the farms that grow wheat, B is the farms that grow barley, and we're told that 70 farms grow only wheat or only barley. So what does that tell us? Doesn't tell us anything yet, so we're going to have to come back to that one. 4/5 of these 70 farms grow only wheat. Okay, now we can do something. So we need to find out what 4/5 of 70 is. So what is 4/5 of 70? Finding a fraction of number, got to divide by the number on the bottom and then times by the number on the top. So 5s into 70 go 14 times, and 4 14s are, what's that, 56? So 4/5 of these 70 farms grow only wheat. So that means that one there must be 56. Well, if that's 56 and so we've dealt with this piece of information then. And we're also told, remember, that 70 farms grow only wheat or only barley. So that 56 added to what goes in here adds up to 70. So we need to have 14 in here. So when I add it onto the 56, I get 70. And then the final piece of information we've been given is that the number of farms that grow wheat is 3 times the number of farms that grow barley. Okay, so we need to find out what the number is in here, such that 56 plus that number is equal to 14 plus that number. That sounds a bit algebraic to me. So I'm going to put an X in here. So the number of farms that grow wheat is 3 times the number of farms that grow barley. So the number of farms that grow wheat is 56 plus X, and that is 3 times the number of farms that grow barley, which is X plus 14. So 56 plus X, the number of farms that grow wheat, is 3 times X plus 14, the number of farms that grow barley. So removing the brackets, 56 plus X equals 3X plus, what's that, 52? 42. 3X plus 42. Rearranging, I think it's easier to put the X's on the right. So 3X take away X. I'm going to move this X over here, take away. And I'm going to move this 42 onto the other side. So that gives me 2X is equal to 56 take away 42. They have a difference of 14, making X equal 7. Okay, now I know all the information I need to fill this diagram in. So I'm taking that X out and putting 7 in. So far I've got 56, 14, which has up to 7, plus my 7, which is now 77. And I know that the number of elements altogether, number of farms altogether is 100. So there must be 100 minus 77 farms in neither. So that's 23, isn't it? So I must have 23 outside of those 2 circles. Done. Question 15. The universal set contains the whole numbers 1 to n. N is an even number greater than 100. O is a set of odd numbers. P is a set of prime numbers. And S is a set of square numbers. So explain why there are no numbers in P intersection S. Okay, well, are there any prime numbers that are also square numbers? No, because prime numbers have exactly 2 factors, and square numbers, well, they have an odd number of factors, don't they? So you can't have an odd even number. So you can't have any prime squares or square primes. So I'm going to write that down. So prime numbers have exactly 2 factors, whereas squares have an odd number of factors. Okay. Part B. How many numbers are there in O union P? So made up of the set O, which was the set of odd numbers, and P, the set of prime numbers. Okay, well, there's only one prime number that isn't odd. So one would imagine if I work out the number of odd numbers and add 1 to it, I'll get the total of odd union prime. So how many odd numbers are there between 1 and n? Now we know that n is an even number. So if I divide it by 2, then I will get the number of odd numbers. And if I add on then 2, because 2 is the, if I add on 1, which is the number 2, it's the only even prime number, then my answer's got to be that one. In question 25, we're told that we've got a Venn diagram. We're told that the universal set is made up of 295 students at a college. Set A is the students who take art, and set G is the students who take geography. So we can see that there are students who take neither, and there are students that take both. So one student at random is chosen. Work out the probability that the student takes art. Well, there are a total of 25 plus 14 students who take art. So the probability that that student selected at random takes art is going to be those 39 students divided by the total number of students, which we're told at the top here, the universal set, 295. So it's 39 out of 295. Now I could cancel that down, but it doesn't ask me to show it in its lowest terms, and so I'm just going to leave it as it is. So one student who takes geography is chosen at random. Work out the probability that the student also takes art. Okay, so this time, this is conditional probability. We are drawing our student from this group here only, which totals 14 plus 29, which is 43. So we're selecting from 43 students, and we're asked the probability that the student also takes art. So those 14 students then who take art also. So the probability of art given geography is going to be our 14 students out of our 43 students. Okay, part C. In this Venn diagram, 295 students attend the college. H is the students who take history, and E is the students who take English. So 1/2 of the students who take history also take English. The number who take English is twice the number who take history. Work out the value of X. So we have to do something similar here, but algebraically. So let's break this down a little bit then. So 1/2 of the students who take history also take English. So if half of the students who take history also take English, then half of them don't. So we've got another X over there. I've got X students who don't and X students who do. So our second statement says the number who take English is twice the number who take history. So the number in the English set is going to be twice as big as the number in the history set, and we know that the number in the history set is 2x, so which means the number in the English set must be 4x. So if there's 4x altogether in the English set and x is in the intersection part, then this part here must be 3x, giving us our 4x altogether in the English set. So we should be in a position that we can now work out x, because we know there are 295 people in the college, so we can form an equation in x and solve it. So our 4 regions altogether added up should be our universal set. So x plus 3x plus 125 should be the same number of students as in the universal set, 295. So x plus 3x is 5x. 5x plus 125 is 295. Oops. So cross multiplying, changing sides, changing signs on our 125 there. It's going to give me 5x equals 295, subtract 125, which is 170. So x is 170 divided by 5. 5's into 170 go 34 times. So x equals 34 is our solution. Question 14 has a universal set of all the numbers between 0 and 1 to 3 decimal places. A is the numbers that round to 0.7 to 1 decimal place, and B is the numbers that round to 0.7 0.75 to 2 decimal places. So work out a possible number with 3 decimal places that is in the shaded area. So let's draw a number line. Let's put 0.7 there, then 0.6 and 0.8 are the numbers either side of those. So the numbers that round to 0.7 are going to be the numbers halfway between those numbers. So anything bigger than 0.65 and smaller than 0.75. But let's consider the numbers that round to 0.75 to 2 decimal places. One number down on the scale would be 0.74, and one up on the scale would be 0.76, and the numbers that then round to 0.75 are going to be the ones halfway between those. So the ones that are bigger than 0.745 or smaller than 0.755. So then the numbers we're looking for then are going to be the ones kind of in there in between the two. I'm not really drawing a very good diagram of that, but the numbers between 0.75 and 0.745. So if I just pick any number which is a decimal number between those two, so for instance 0.746, then that one would be fine. Part B asks us for a number to 3 decimal places that will be in this shaded area, which is in the set A but not in the set B. So something that doesn't round to 0.75 but does round to 0.7. So we could pick any number from here up to here. Quite a lot of choice. I think I'm just going to pick one from somewhere here. It just needs to be any 3-digit number. Any number to 3 decimal places. So I'm going to pick 0.666. Don't know why that number came into my head, but that one rounds to 0.7, but obviously doesn't round to 0.0 and 0.75 to 2 decimal places. Part C wants us to find another number to 3 decimal places, this time that's in the set B and not in the set A. So coming back to our little diagram here, it's going to be the numbers up here then, isn't it, that are going to round to 0.75 to 2 decimal places, but won't round to 0.7 to 1 decimal place. We're going to have to pick a number somewhere in this range. So bigger than 0.75 but less than 0.755. So I'm going to pick 0.752. So 0.752 works in there. So you can see that one does round to 0.75 but won't round. If I try and round it to 1 decimal place, it'll go up to 0.8. So it's in the right place. And then finally, work out a possible number with 3 decimal places that is in the shaded area. Okay, that is not in set A or in set B. So again, coming back to our diagram, it's going to be any number that is outside our range, so anything down here or anything up here. Okay, I'm just going to pick something down at the 0.6 end, but you've got lots and lots of choice here. So let's call this 0.601. That will do. Lots and lots of choices, but that seems okay. Question 12. A whole number from 1 to 15 inclusive is picked at random. So our universal set is whole numbers from 1 to 15 inclusive. M is our multiples of 3 and F is our factors of 24. So using the Venn diagram to work out which of these probabilities is greater. Okay, so let's have a think about what we've got here then. So I've got 15 numbers. It might just be worth putting all the 15 numbers in. So we need to decide if each number is a multiple of 3 or a factor of 24. So the number 1 is a factor of 24 because 1 is a factor of everything but not multiple of 3. 2 is a factor of 24 and not a multiple of 3. 3 is a multiple of 3 and a factor of 24, so it belongs here. 4 goes into 24 but it isn't a multiple of 3. 5 is neither, so 5 can go on the outside. 6 is a factor and a multiple, so it can go in the middle. 7 is neither. 8 is a factor of 24, but it isn't a multiple of 3. 9 is a multiple of 3, but not a factor of 24. 10 is neither. 11 is neither. 12 is both. 13 is neither. 14 is neither. And 15 is a multiple of 3. Okay, so I've put all the elements in. Just double check I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now we can work out what the probabilities are then. So what's the probability that the number is a multiple of 3 given that it's a factor of 24? So the probability that it is a multiple of 3 given it's a factor of 24. That means it's in the F set. So what's the probability that it's within the F set? So somewhere in here. So I'm going to pick from this group, and it is a multiple of 3. So it's going to be the 3 multiples of 3 out of the 1, 2, 3, 4, 5, 6, 7 factors of 24. Or what's the probability that the number of the factor of 24 given that it's a multiple of 3? So the probability that it is a factor of 24 given that it's a multiple of 3. So this time it's going to be the numbers inside here. So it's given that it's a multiple of 3, so the number must have been picked from this group. So how many multiples of 3 are also factors of 24? There are 3 of them, so it's going to be 3 out of 5. So that one is 3 out of 5. So work out which of the probabilities is greater. So they can just say that which is bigger, 3/7 or 3/5. I think 3/5 is greater. So let's just label this one as the greatest, as 3/5 is bigger than 3/7. Question 18 is a Venn diagram, always my favourites. A school has 86 teachers, 42 are male and 44 are female. 1/3 of the male teachers have blue eyes and 1/4 of the female teachers have blue eyes. So we're going to put that on a Venn diagram. For A, we're told that the universal set is teachers in the school. M is the male teachers and B is the teachers with blue eyes. We need to complete the diagram. Okay, so where shall we start? I think if we look at this bit here, 42 are male and 1/3 of the male teachers have blue eyes. That means we can work out what the intersection is going to be then, don't we? So we've got 42 male teachers altogether and 1/3 of them have blue eyes. So 42 times 1/3, or 42 divided by 3. 3 goes into 42. Is that 14 times? So that means there are going to be 14 male teachers with blue eyes. So that means the intersection between M and B is going to be 14. And now I can start working out the rest. So if there were 42 male teachers altogether, of which 14 had blue eyes, then 42 subtract 14 will be the number of teachers who are male and don't have blue eyes, which is 28. 1/4 of the female teachers have blue eyes. How's that going to help us? Oh, okay, I suppose that tells us the bits that are in the number who are in B and not in M. And we know there are 44 female teachers, and 1/4 of that would be 11. So that is that one there then, isn't it? So 11 teachers have blue eyes and are not male. And now we can work out what's left. We've got 86 teachers altogether. So then 86 minus my 3 other parts, 28 and 14 and 11. So that's 42 plus 11. 53. 86 to subtract 53, which is 33 female teachers with not blue eyes. That's what's going to go there, isn't it? Part B says one teacher who has blue eyes is chosen at random. Work out the probability that the teacher is male. So we want the probability that the teacher is male given that they have blue eyes. In other words, if we know that the teacher is in this group, what is the probability then that they are here? So that's going to be, there are 14 teachers with blue eyes out of a total population of 25 teachers with blue eyes. So that is going to be 14 over 25. Question 18a. I've got a Venn diagram here with an area shaded on it, and we're asked which of these represents the shaded region. Is it A? Is it B dash? Is it A intersect B dash? Or is it A union B dash? Okay. Now this dash means not, doesn't it? So B dash is not in B. So clearly the area is inside A, but it's not all of A. And clearly the area is outside B, but it's not all the area outside B. It's going to be one of these two at the end, isn't it? It's going to be either A intersect not in B or A union not in B. Now another way of reading these intersections and unions is using the words and or. A intersect is the same thing as and, really. You can think of intersect as and. So is it in the set A and not in B? Oops. Or is it union, which we can read as or? Is it in A or in the or not in B? Well, I think it is this one. It's in A and it's not in B. Because if it was in A or not in B, it would also be this area around the edge here. That would be A or not in B. So not that one. It's A and not in B. In question 18b, I've been given another region on the same diagram, and again I need to find the correct set notation to use here. Now remember what I was saying earlier, that union is the same thing as or, and intersect is the same thing as and. Maybe that helps. So let's see if we can decode what some of these things that I've written down here. What is A union B? Well, A union B is the intersect of... No, it isn't. A union B is everything inside A or everything inside B. So then the not that then is going to be everything not in that intersect. It's going to be everything on the outside. So I think that's the one we want, isn't it? It's that one there. Let's just double check. A intersect B is just a bit in the middle, and then if I flip that round, that's going to give me everything on the outside plus that bit plus that bit. So the only bit that's left unshaded is a little teeny tiny bit in the middle. So it's not that one. Not in A intersect B. So not in A and in B. So that is just going to be that bit there, isn't it? Not in A intersect with B. And then this last region, not in A union, not in B, is the same as the one we had earlier. So not in A union. So I can shade all that, and I can shade all that, and it just leaves me that little bit in the middle again. So yeah, it's definitely that first one there, A union B dash. Question 14, we've got a Venn diagram. Now this little squiggly E stands for the universal set. So the universal set represents 31 students in the class. So that's the total number of things being represented inside this Venn diagram. C is the students who have a cat, and D is the students who have a dog. One of the students from the class is picked at random. Work out the probability that the student has a dog. Okay, we've got a bit of algebra to do first, because we've got some algebraic values here and here, but there should be no problem for us to work out. If you remember, we've got 31 students altogether, so if I add up all the different values in each of the ranges of my, or the different areas of my Venn diagram, it should add up to 31. So if I take my 6 and the 5 and the 2x and the x plus 2 and I add it together, that must be everything. That must be my 31. Okay, so I've got a linear equation in x that I can go on and solve. So collecting like terms together, I've got numbers here at 6, 5 and 2. That adds up to 13. So I've got 13, and I've got 2x and x, which adds up to 3x. So 13 plus 3x equals 31. Taking my 13 over to the other side, I'm going to get 3x equals 31, subtract 13. 31 subtract 13, 31, 21, 18, isn't it? So 3x is 18. And then finally, to find x, I can divide through by 3. X equals 18 divided by 3, x is 6. Okay, now remember, that wasn't the question though. The question wasn't find x. The question was work out the probability that the student has a dog. Okay, so the probability of success is, so probability of a dog is going to be successful outcomes, how many students there are with a dog. Okay, so we've got 5 people who have a cat and a dog, and 2x people that have a dog. Now we know that x now is equal to 6. So there's actually 12 people who have a dog then. 2 times 6 is 12. So that's 12 people have a dog only, but the students who have a dog is going to be both those added together then, isn't it? So it's the 5 and the 12. So there are actually 17 students who own a dog. So probability of success is successful outcomes divided by total outcomes. Now there are 31 people altogether in the universal set, so that means 17 out of 31 is our probability. Now normally in probability questions you don't get any credit for simplifying or breaking that down in any way, so you may as well just write down the answer as 17 over 31 and don't risk making an error by trying to simplify it in some way. I'm not sure you can anyway, because 17 is prime and so is 31. Don't think it's going to simplify anyway, so let's just leave it like that. 17 over 31, that's my answer. So question 14b says one of the students who has a cat is picked at random. Work out the probability that this student has a dog. Okay, so this is what we call conditional probability. We're being asked what's the probability that someone has a dog given that they have a cat. Okay, so what's the probability that they have a dog given that they have a cat? Okay, now if they've got a cat, it means, let's just tidy up this Venn diagram for a second. Let's just get rid of all that blue. Okay, if they've got a cat, then they're somewhere in here then, isn't it? They're in this purpley bit. So there are 11 people altogether in that purpley bit. So given that they've got a cat, they must be one of those 11 people. And of those 11 people, 5 of them own a dog. So the probability of getting that they have a dog given that they have a cat is going to be 5 out of 11. 5 out of 11.
Question 22. Which of these represents the shaded region? Circle your answer. So A intersect B dash. Let me just draw a quick sketch of what each one of these are. That is the union of everything in A intersects with things not in B. Okay, so that is just going to be that bit there. Okay, inside A but not in B. That's A intersect B dash. B dash, the complement of B, is everything outside B. So that's going to be this bit outside plus this bit in here. So that isn't it either. It's close, but it's the middle bit that's different. A union B dash is everything inside A union with everything outside B. So everything inside A, so that is all that bit, union with everything outside B, which adds this bit on here. So I think it's that bit there, isn't it? It is that one. So what's A dash union B dash? Everything outside A union with everything outside B. Well, everything outside A is everything outside of that circle, and everything outside B is everything outside of that circle. So everything outside either circle is going to be kind of everything bar the bit in the middle then, isn't it? It's going to leave you that little bit in the middle. Okay, so yeah, it's that one there, A union B dash. Question 25. The Venn diagram shows some information about 150 students. So that little squiggly E stands for the universal set. That's the set of everything involved in this question, and it contains 150 students. C is the students who study chemistry, and P are the students who study physics. So you can see that we know how many students study physics only and chemistry only. We don't know yet how many study both or how many study none. So I suppose the question is going to be around that then, isn't it? So the probability that a physics student chosen at random also studies chemistry is 5/12. One of the 150 students is chosen at random. Work out the probability that the student does not study either chemistry or physics. Okay, so my thinking is that this 5/12 here we're going to use to find x, and once we know x we can work out y. Okay, that's the plan anyway. So the probability that a physics student chosen at random also studies chemistry is 5/12. Okay, well, probability is successful outcomes over total outcomes, isn't it? So probability is successful outcomes over total outcomes. Now we know that the probability is 5/12. What else do we know? Do we know the successful outcomes? Successful outcomes in this case, probability that a physics student chosen at random also studies chemistry. That's the number in the intercept, isn't it? So that is our x. X is our successful outcomes. And then the total outcomes is everyone in the physics set, which is our x and our 35 combined. So then that's going to be x plus 35 down there. Okay, so we know that x divided by x plus 35 is equal to 5/12. Okay, I'm going to cross multiply this. So I'm going to move that up there, and I'm going to take the 12 and I'm going to move it up there. So that gives me 5 lots of x plus 35 is equal to 12x. Multiplying out the brackets, 5x plus 5 lots of 35. What's that? 70, 140, 175. Plus is equal to 12x. Okay, taking 5x off both sides, 175 then is equal to 7x. And 175 divided by 7 then. 175 divided by 7, 25. So that tells me x is 25. Okay, so I've got 25 students in here then. So now I can, well, I know that altogether there's 150, and I know everything apart from y now, don't I? So I know that my 47 plus my 25 in the middle plus my 35 plus y is everything, and that is 150 students. Okay, so adding these together, what's that? 47, 25 and 35. Well, 25 and 35 is 60, add 47 is 107. So then y then is 150 subtract 107, and 150 subtract 107 then is going to be 43. So y is 43. Y equals 43. Just checking I've answered the right question. Work out the probability that the student does not study either chemistry or physics. Okay, so that isn't the answer. I found Y, but the probability then is successful outcomes over total outcomes. So the probability of neither, which is 43 over 150. 43 successful outcomes over a total of 150 outcomes. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.